With the COVID-19 virus, we decided to focus our problem-solving efforts on how the virus spreads. The main problem we looked to solve was crowded indoor places, which is especially important in a lively environment such as Purdue. There are few central hubs of activity normally overflowing with students at all times. This is a large problem, as under CDC's guidelines, a 6-foot distance apart is recommended at all times, as well as a face mask to reduce the spread of the virus. In crowded environments, the 6-foot distance is almost impossible. This is the problem we analyze most.
From all the research that we did, we found several apps which predicts the amount of people there are at a specific place in peak hours. But we found that these apps do not have a very precise way of calculating the amount of people there are. Instead, we plan to use the Purdue Wi-Fi network, which will tell us the amount of people connected to the network, and this way we have a much more accurate way of predicting the amount of people there are. Also, there are some other apps which shows people who have self-reported symptoms like fever, cold, cough, and breathing problems, which are very common for COVID-19 patients. We think we can also add the same feature which would alert push and give them the medical attention they need.
So, our solution. Our plan is to make use of pre-existing technology such as motion sensors to effectively monitor and display the occupancy of indoor spaces on our app in real time. Our solution would benefit the current students and staff at Purdue that will be on campus this fall. This website or app would allow them to check how occupied indoor places like combined study spaces and libraries are so that they can plan their time accordingly. So instead of going to walk when it's crowded, they could check the occupancy level beforehand and decide to go to a different location. This limits their unnecessary exposure to other people and reduces their chances of contracting COVID-19. Furthermore, we plan to implement trend analysis into the app so that it can predict and display the expected occupancy of the various locations throughout the day. This will further aid our users to plan their day further in advance. To communicate and promote our idea, we can use posters that we can put up around the campus, and we can also use the Protect Purdue website to raise awareness of the app.
Our plan to develop the solution is to integrate a feature on the current Purdue app, which most students usually use to check on their laundry. We will add an occupancy tab under the personal section as shown in the picture, which will constantly show the occupancy of indoor spaces such as walk. This will always be accessible and handy to all students and faculty members. And this can also encourage more students to download the app, which will then display more accurate numbers and trends. We will complement this with a web page to allow people to access occupancy numbers from any device. Our roadmap going forward is to first start working on integrating the solution with the Purdue app. Then our second step will be followed with the website. And the third step is to install digital occupancy counters at the entrance of buildings at major locations such as Walk and Hicks Library, which are frequented by students.
Not all students on the campus have the Purdue app installed on their phone. Furthermore, the Android operating system and iOS seem to have different Purdue apps. The second major challenge we will face is that there could be a lag in the system, which may represent inaccuracy in the numbers displayed. The cost estimation. We already have Purdue apps for iOS and Android. Hence, making another app would not be necessary, and just adding a section to it should not be costly at all. The website is also easy to make, and we will use volunteering from students who possess the required skills. Digital signboards should cost around 200 to 300 US dollars and be fully customizable. Also, we will be using a system of 2 motion sensors on either side of the doorways, and we have estimated $2 for each sensor.